Okay, so we're still in chapter 1. Everybody should know that the reading assignment for the weekend is chapter 1. So far, we have covered a little bit of the history. Compilation execution process is not only covered in class, but we actually experienced that in the last Monday. Machine language is a high-level language that has spoken a lot about computer, and has a lot of information inside. Creating an algorithm is the assignment that you just completed, and we talked about the programming lifecycle, and we continue to talk about those. Of course, we all know what computer programming is. Let's get started on some of the computer components. And I will definitely work with you in slides as well. Don't be shackled by the absence of these slides. Let me explain what happens to a lot of people, not just my class students, but people in general when they start dealing with information sources. They rely on that information source. And that information source goes away. Because I can't study for your exam, so you didn't put your power slide in the web. Your PowerPoint slide in the web. You really think I'm going to be sympathetic? Do most professors put their PowerPoint slides on the web? They do, all of them? But you also get your grades in those classes too, right? So don't let the fact that, well, your system didn't report my output. Don't let it bother you. All right? As long as you can print it out for me or you can prove it to me through email, you did it when you said you did, I'm not going to rely on this 100% grade. But you should be cautious. You can lose your work. One way to make your work more efficient is to use an information utility, an intranet, as it's called for our course. That's another way to use all your information if you don't see it. You're not careful. Back up everything, ladies and gentlemen. Ladies and gentlemen. So, we went over this very simple algorithm about how to compute a payroll amount for an employee, and we discussed a brief bit about languages in general. So I'm going to move forward past a lot of this. Can you help me with the zoom in? Zoom in with the small here. All the fun. Spoke about comments. Anybody remember what I asked you in regard to comments for your work? Yes, sir, back. Good. Got it. The algorithm that you turned into me on in general on Thursday. I may have some exceptions to the holiday. Big and fine. Most of the time, only that algorithm, submit that algorithm on Thursday. When you work on your program to be submitted on Tuesday, I want you to copy the comments that corresponds to the place in the code where you now are doing that part of the algorithm. And that's when you move your comments. Of course, you know how to compile now. It's very basic compile program. Hopefully everybody has discovered these ones. And we'll begin to work with main programs and sub-programs, but we know the concept here because we took a look at the party structure chart. So, as we've been moving forward in systems engineering or systems development life cycle, one of those cycles is, one of those phases is the implementation phase. Here you test the program, you running it, seeing it produce the correct results, and remember our test oracle, which is our hand calculation of given data values through our algorithm, gives us our way of comparing our output from our program and making sure that we have the correct results. And the whole process of making our programs work bug fixing, bugs are found. You may even find bugs in my code. I'll modify that code, but I'll modify it within some reason. I'm not going to make any major overhaul of the system. But I'll make sure it continues to work and stays up. Sometimes my server may even go down. It may not. There's no C for you?
Is it around? Kid.
What's on right there? You working on your laptop? I can. You can? Okay, why don't we just get it down a chair? This seems like a strange thing. It says that maintenance accounts for the majority of the effort in most programs. Maintenance. And there have been a number of changes in the engineering approach to systems to try to address this major drain in resources. But what it basically means is that if you're trying to produce a piece of software, the large amount of your time and your money will be spent after you have fielded the software. That's saying that I build my house, and keeping it clean and keeping it up will cost more than the house itself. That's a strange phenomenon, but it happens in software and it is a big problem. So there are a number of measures that are taken to address that. One of them we discussed, reusability. Somebody writes a program that will display stock market prices, updates every 20 seconds, puts it into a library, and everybody who needs stock market prices in their application can draw from that code and use it. The word that you'll be, command that you'll be using to do this is an include statement. An include statement. And you'll notice that all of your programs generally are going to begin with an include statement. Generally include IO stream. IO stream provides the source code for a library of functions that have been written by somebody else, tested and reused now in your program. Those particular elements in that library are cout, which is used for outputting, and cin is used for inputting information into your system. So it's a lot of different libraries. As a matter of fact, it's one of the ways in which the cost of the legal systems has been reduced significantly. So now you don't have to write your own string manipulation function. You don't have to write your own date and time manipulation function. You can grab code from someone else's library, and there are standard libraries for C++ that are available inside the system as we sit here, and there are others that you can get off the web to use code. So reusability is one of the ways in which the long time and amount of money has been reduced in maintaining software. The other thing is comments. When you look at code that is very complex, you'll realize the benefit of comments. You'll realize the benefit of your own comments when you look at your program the day after you wrote it. If you comment your code and say what you're trying to do, and something goes I like this slide. It's sort of meaningless in some regard, but it does perhaps try to demonstrate a problem that you all encounter, a problem that I'm going to help you not have. And that is, a lot of people, myself included in you, have a program to write. And you go down to, you won't write an algorithm, you don't think about it, you go to the machine and start typing. Everybody has done this before. You have a paper to write. Everybody tells you an outline, you have every bibliography you put together, outline your paper, put your ideas down, put your ideas, now put stuff together. That's the way to do it, honestly. Maybe when you're putting stuff to not do it that way, but you and I write together, I have to outline first. That's kind of what we're talking about here. We think about the solution. We produce code too quickly without going through the process myself. Exactly out. We've got to really go about it. This thinking process that I'm describing here is what you're going to be doing as you put your algorithm together. And then you're going to code. And that process is a shorter path from your starting point to your goal. And if you just start coding without thinking first, you debug, revise, debug, revise, debug, revise, and you get to your goal, but it takes longer to get there. So that's why I'm trying to build in the discipline of thinking about the problem enough to put together an algorithm before you start writing the code. It's going to be tedious. I'm sure you're not going to like it very much. Because I'm going to ask that you do that and you must submit an algorithm before you submit the code. And it's akin to, you got to produce a architectural diagram before you build my house. That makes sense. You got to tell me what it is you're trying to get accomplished before I give you the go ahead and go ahead and start. So that's what I'm trying to do. So just a bit of quick information. I used to go into much more detail. This is much more important than this past, but I'll go over real briefly here. And what we're working with inside the system here is a representation of knowledge, which is in bits. A bit is a 1 or 0 value. 1 or 0. It's either off or on, magnetized or non-magnetized, but it's the way in which information is being stored and represented now. Now, before we get down into all the details, let's just talk about digital information. Everybody knows that we are going to digital broadcast only. Digital broadcast only. What is it, February 17th? Sometime around the middle of February, right? Everybody understand what that process is all about? Let me try to explain it to you. Right now there's 2 broadcasts of every channel. Talking about the broadcast channels, 4, 5, 7, 9, 1, 2. Those channels, not the cable channels. Comcast, US station. The broadcast. There is an analog broadcast, which is picked up by TV antennas and are used to feed the systems that are analog TV. And then there are the digital broadcasts from the same broadcasters that if you have an antenna and a digital TV, which probably most of you, digital TV is the one who wasn't that you will see a digital output, a digital screen representation of the broadcast. So maybe I should ask a question. Has anybody ever seen an analog TV? Seen an analog TV? What, in a museum or somewhere? Okay. So what happens when the signal gets weak? start getting weak and start getting big. That's because every pixel, every dot on that screen is represented by 8 bits. 8 bits describe the color of that pixel. Everybody understand what I'm saying about these pixels? Pixels are the light dots that are on your TV screen. Pixels are the screen. The screen that you're looking at here is made up of, I don't know, thousands, 2,000 pixels. Each place on the screen is a color dot. And by putting together the bit representation of bits, 1 or 0 representation in sets of 8, those pixels get their color. So the broadcast of digital information is a string of 1 to 0. What's the good thing about the string of 1 to 0 versus the analog like radio signals? Everybody coming? Well, you think there's more chance of error in a 1 to 0 string versus a measurement of binary type of thing? It's less. It's not just less, it's also error correction algorithms that if a bad set of 1 to 0s are received by a digital receiver, it will know that's not an allowable set of 1 to 0. I don't know what you mean. A signal will be sent back to the source, and to resend that, make sure, something didn't happen in transmission. So repeating some back and forth to make sure that the signal is good. There's other reasons, too. Cassette tape. Actually, some cars still have cassette tape. Some people actually use cassette tape. Everybody here, I'm sure, at least at one point will have seen a cassette tape. Analog device. Analog storage. On that tape, there is a magnetized set of progressive imprints. Those imprints make the sound in an analog receiver. But now we deal with TVs and DVDs. Digital storage medium. They last longer. They're not subject to magnetism. You can destroy them. You can scratch them. But even scratching them is sometimes very difficult. Okay? So now we have media that is stored in a way that it will not degrade. If you play your CD 1,000 times, careful with handling it, it's going to play the same time 1,000 times as it plays the first time. There's no degradation in the quality. If you play a cassette tape 1,000 times, you're not going to have any sound after 1,000 times. It degrades every time you play it because that magnetic image gets degraded by magnetic fields in the air, magnetic forces that push next to another machine or leave it underneath and so forth. It warps and degrades that signal. So that particular medium is not a very good way to determine the information. So the digital age is giving us a lot of benefits in regard to not only the quality of the information and recording and video, but the way in which that information can be maintained and degradable level, and maybe even more important, the amount of information that can be stored in a given physical, like a Blu-ray disc versus a DVD or a, I don't know, they have double density CDs versus single density CDs. Right now, a lot of information can be stored in a very, very small amount of space. And we can see that this whole technology is beginning to increase. I see everybody here's got a cell phone. And I would bet many of your cell phones, you've got a library of email. I bet your cell phone is probably get your iPod out the password. Why? Because now the amount of information in a digital way that can be stored in that camera's memory is so huge that you can now store all your music memories in your phone. So it's going to increase. We've seen a real movement in the way in which you analog bandwidth, the analog portion of the broadcast band is now going to go to cell. So FCC, Google, Yahoo, and a lot of other major firms are battling back and forth as to who can buy those airwaves. Because if you can get those airwaves, you can start to infiltrate the market share of cell phones. So what, and I haven't kept up with all the expenses. What I can remember is that Google and Yahoo and a number of other larger companies have got together to try to buy those airwaves. And they can buy those airwaves. They're going to replace cellular phones with phones that are pretty much free. And what you'll be paying money for is the utility of using an airwave will be free. You're not going to pay a monthly rate. What you'll be paying for is the actual application, like a Microsoft Word or PowerPoint software package that you'll now buy from them. Or you'll buy a utility. Or you'll buy information about a certain subject from them. So they're going to try to open it up so that, like TV used to be free, not about TV just used to be free. You got free cell phones. They're trying to get cell phones free. They get cell phones free. They can bring the stranglehold that AT&T and Verizon and all these that's why it's fighting. That's why Congress and the government got to get involved. These huge giants are trying to carve out a market share that really will affect the way we all live. So right when the government get involved, the FCC sort of gets them step back and say, hey, we'll sell you these airways, but here's what you got to do. Otherwise, you're either paying a lot of money for it, or we are going to be pretty much dictated what we pay. Right now, there's a lot of freedom that we don't have to use cell phones that we like to have. For example, if you notice that in the last few years, back when I first got my cell phone, it was like, what you want? Hey, okay, bye. 5 minutes of discussion. What's call? Matter of fact, just send me a text message and I'll call you back. I only have like 100 minutes and it costs me. Now, does anybody worry about minutes? Don't worry about minutes at all. And if you're in my favorite 5, we can just keep the phone line open all night. You just, wake up in the morning, hey, how you doing? I'm still good. It doesn't even matter. Minutes don't matter. So if we're not careful, somebody may take that freedom away from us because they've got to pay for that. And so that's why this whole thing is battle. But this whole digital age is very interesting, and I'm not going to talk to you more about it. Go on. So the actual process of recording information is in a binary coding system. Binary coding system is basically we generally use a decimal system. So if we want to record a number in binary, in a byte, because also the numbers, the most simplest thing is information that's stored in a computer in a binary integer decimal form is a number. So, let's say we have 8 bits. Each one uses a bit. 8 are called a byte. And our storage measurements now that we talk about are So it would be 2 to the first power plus 2 to the power. Here's a, I'll represent the number 15. 7 at, how would you represent the number 8? Yeah. So how would we represent the number 9? How would we represent the number 10? 11. 12. So that's 2 to the 0 here, 2 to the first, 2 to the third, what's 2 to the fourth? 3. Four times 4, right? So how would you represent the number 16? 0, 0, 0, 0, 1. So that's how you represent it. Because this decimal, this place is 2 to the fourth power, or 16. These are 0. So 17 would be that. 2 to the 16th power, 2 to the fourth power, or 16 plus 1. It's not important. I just want you to get the so like binary arithmetic. We have coding systems. So if we're dealing with a variable, if we're dealing with a place in memory that has a byte of memory represented, is empty. And we want to represent the color light green on a pixel that corresponds to that stored information. There needs to be a coding scheme, right? I mean, if we make light green that, right, that's the same code as number 1. That's okay. So we don't have to use the same pattern of 1 to 0. It's the coding scheme that dictates how it's interpreted. So the coding scheme for colors might be the same as the coding scheme for fine light. The various coding schemes our book talks about everything in math. Chapter 1 talks about the primary ones that we use to represent knowledge. There's a correspondence between a bit pattern and a English recognized symbol, letter, or something of that nature. Symbol, letter, actually, or punctuation. So, even with the same idea of digital representation, your programs, when they are compiled, are translated from the digital representation of your type string instructions into another digital representation called machine code. Machine code is a coding scheme in some regards, but it's a digital representation that the computer understands in order to perform the job of executing the code. So the process of compilation is using machine code. Machine code is generally not portable to a machine. Machine code is created by compiling algorithms. It runs on a specific type of computer and made in a binary code instruction, and a language that can be directly used by the computer. High-level languages, C++ being one of those, are portable. So you can take the code you write here on this machine and take it to another machine, and it will be compiled in that machine's machine language. So the code itself, the English-like statements that you write, is transportable between machines. And here's some of the Java was the first attempt to produce a coded output from the compilation process that was transportable to the machine. And I don't want to go into a lot of detail about what Java did and didn't do, but it was partially successful, and it's still partially successful in terms of completing that process, and that is being able to produce a piece of source code on any machine, compile it into a Java representation, and then taking that representation and moving it to any number of machines, and that number of machines can understand it because it has a Java virtual machine. Again, I'm not going to go through all of that. It goes beyond this. The process that we do here every time we write a program and compile it is that we write it in C++, the compiler uses machine code, and then if you haven't noticed, there is a single last step that gets done, and it's called linking. Okay, linking is a look at linking as the process of taking machine language and incorporating into it other libraries that are maybe unique or related to your particular machine. For example, let's say we have a print statement in our program. And the printer that we are using, I'm not going to do this. This is probably not important to you guys. So I'll just say that the linking process builds in some of the standard library reusable code in the system to create a file with a .exe and a executable that students can execute consistently. So you double click on that exe file and it's executed. But you can't do that with just a machine like this. So again, I don't want to go too much detail here. You don't need to know all of it. Just get the idea of what's going on. I want to get, and I'm not talking about Java. Here's where I want to get to next. We talked about this scientist by the name of von Neumann. Von Neumann came up with this architecture. This architecture is the architecture of getting every computing device I think we're going to encounter in our lifetime. People have experimented with different other architectures, but this is the architecture that is accepted as a standard out in the computing spectrum. I may have alluded to the fact of why this is so. Okay, anybody who's speculating having looked at this picture in the course read chapter 1, why this architecture is so universal? Well, let's take a look at some of these things. Does this architecture remind you of anything? Besides the computer? What else has memory? Yes. The human mind, right? It's like the brain. Actually, it's like our consciousness. I'll explain to you an analogy here so that you understand it. It's very much like our consciousness, like how we operate, how we process information. This box here is called the central processing unit. In this central processing unit, there are a number of different components, but those components are divided up into general categories of control unit and arithmetic logic. The arithmetic logic unit is where the logic or the reasoning or mathematics takes place. The control unit controls how the software and system execute. So if you're calling a function and giving execution control to that function, that process of handling that execution transfer is done by the control unit. Inside that function, if you're doing some arithmetic, it'll be done in controls here in the arithmetic control unit. And when that information is now sent back to the calling function, so execution control can continue there, the control unit takes over. So there's a lot of interaction between these two. Do we have a control unit? Do we have an arithmetic logic unit? How do we? We sequence things. We establish sequence. Like right now, you're probably looking at your watch and saying, okay, my next class is, or I'm catching lunch class. You're sequencing things that are have RAM and we also have registers. Look at RAM as being our long-term memory. Look at registers as being our processors right now. Let's figure out what's going on right now. Well, I'll hold on to that. So the computer has long-term memory, and then it has registers. Registers is where the information is going to be retrieved from RAM, so that this arithmetic logic can work on it very quickly. Like our conscious mind now has about 7 to 9 different thoughts going on at the same time. You can hold on to the average mind and handle about 7 to different 9 general abstract concepts simultaneously. They say, chess masters can hold 20 to 50 different things in their mind. Geniuses can hold 100. So the average person can hold about 7 to 9. So you can look at a register as being a piece of information that is being operated on that computer. We have over here. These are our peripherals. These are our senses. This is how we get information in and out of our computer. What's our input device? Right there. Eyes, ears, smell, touch, our senses. How we communicate, how we get information from our environment. Comes into our input device. We have output devices.
Yes.
We just use one, right? Our mouth. Also, mannerisms, we just use some of our output. Also, leading resource device. Very good. I'll tell you why that's called leading resource device. When you're working on a Word document and you're typing it into the CPU, into the memory, into the RAM of the computer, and the power goes out, what happens? Gone. Volatile. That's the word. Volatile. That storage device is not volatile. That's the hard drive. Save it to your hard drive and it'll be around for you tomorrow using the power of the computer. Plug out. But don't save it here. And this power goes out. Wow. We are using and often use storage devices too. Recorders, taking notes in class. Okay. Why do we take notes in class? So at night you can reinforce that knowledge into your long-term memory. And when it comes time for the exam, it's more readily available for you to come to your registers or your consciousness and place them in that spot in that exam. So you do have vivid memory for things because this is limited. Even our long-term memory, although it's very, very big, it's got some finite to it. I don't know what it is. Time is only 7 years or decades, I'm sure, about how things are stored in our long-term memory. But one of the measures of intelligence, again, debatable measures of intelligence, is how much you can remember. And even more so, how quickly you retrieve certain pieces of information from your long-term memory, put them into your consciousness, and replay them, teach them, write them, perform them. Everybody get an idea of why this design works well? Because it's so innately part of how we think that our computing devices, even like ourselves, will work more efficiently in ways that we can identify. The better our peripherals, the better camera you got, the better CRT screen you got, LCD output you got, the hard drive you attach to your computer, our access to information is so great now, it changed the way we live. We take it from the ways in which it changed sleeping and process that's changed too. How many people remember telephone numbers? Have you noticed that? But have you noticed that as life progresses, you don't remember as much as you used to remember because you rely on these storage devices to hold these numbers. Somebody wants to exchange information with you. When you meet somebody and maybe you're classmates, I want to work with you, some homework or something, and you exchange information. What do? You say, what's your telephone number? You get a piece of paper and pen and write it down. You pick up, whip out a cell phone and say, call me. Right? And maybe just maybe you'll put a name after their contact later. That's it. I know my phone. I don't know. This is all in the cell phone. What's the problem with that is what? Volatile. Right? SIM card, you got what? You drop that thing and I got out of the car, I headed to the airport, and I got out of the car, and the cell phone dropped out of my pocket, and flew away. And that trio was like, I thought I was going to body I'm so vulnerable to the volatility of my information. I become so dependent on it. And we've all had this frustration. You go into a store and you say, look, I want to buy this new store because I can't do anything for you. My system does. We depend upon these devices too much, and ultimately, sometimes form, but we use them. But we have been benefited by this information approach of storage, and we have been able to use it. I bet you cannot sell well as you used to be able to sell. Why? Spell check. Vocabulary of speaking. This has been studied and written about. Is degraded. Your vocabulary, the number of ways in which you can express yourself is degraded. Why? Because when you write, you use thesaurus, one-line thesaurus, so many words and so forth. So this dependence upon information is both good and bad. So I think we all have to make some decisions in our lives about how we're going to address this information situation, such as not looking at your email now while I'm talking. That's part of our information downfall. Is that now I'm giving my class in a lab where you've got unlimited library of resources available, unlimited. So the temptation of going there for entertainment and staying here for education is very great. So please, don't take this temptation. Focus up here for a while. I think you'll find it better for you. But let me not say too little about any resource called the internet. Okay? When you, I don't know how it goes, there may have been a time in your life when you went to the library. Okay? How much do you go to the library now? Somebody just write up a research paper on something? How about that? Somebody asks you another class, another research paper, what do? Internet. Somebody asks you a question about football question. Arguably, my son argued about football question. What do you think we did to sell that argument? Google it. So our access information is the biggest library, the biggest resource of information that we ever had in the history of mankind. And it's expanding exponentially. You can just about find any information you want, at least in some regard, on the internet. So what's the problem with that? Jermaine that you might think about that before we move too much further. What's the problem with that? You want to think for yourself. And like many things, we trust don't say what you're really thinking. I know, you know what I'm talking about. So, so we as hopefully mature individuals understand the dangers of the proliferation of bad images and bad info leads to make personal decisions for themselves in regard to how much we will eventually be handled or find. It's very dangerous. Things about building bombs, things about how to murder violence on top of violence, more violent than any, video game you ever imagine you find on the web. So use it wisely. Something that we do so. Okay, I'm going to have a few more comments. Okay. So I should say a little bit about the memory unit inside the computer. It is like an electronic system where each of the intersection of this electronic city has an address. And that my address is 11 stereo. That's my address. Like the address of that particular location could be, 01173. At that address is stored a byte or 8 bits. There can be something stored at that address. A number, a letter, a symbol, some representation of information that's going to store in the data. To retrieve it, the CPU, the arithmetic logic unit, the control unit, will go to those addresses and pull out that information. But information is stored in a finite set of addresses. Someone sells a computer and advertises that it's got 4 gigs. How about 200 gigabytes of hard drive space? It's talking about 400 gigabytes of usable bytes. And so when you run a computer program, your program is just in some portion of that memory. And your data might be stored someplace else. And it's finite, it can get filled, and so the larger the computer, the more data it can hold in its memory, and the more size of programs it can use. We have huge programs that we use. This Visual Studio is huge. One of the biggest programs around is Microsoft Word. And they actually execute, this is the operating system are huge as well, taking a very big portion of memory. That's why our computers have a large now, this is called the stored, well, I don't think you probably know this. Stored data concept. I'm not even sure it's still called that. That's what it's called nowadays. Stored data concept. So, okay, there, store your data, store your computer program. That's a big deal. The big deal is that now you have a device that can turn into any number of different other devices because of this concept. By putting into it a program and some appropriate data, you can turn your computer into a video editing machine. You can turn your computer into a payroll check printer machine. You can turn it into a DVD player. You can turn it into any number of different devices. I don't even know, but do people still have stereo systems anymore? Some people still have stereo systems? Very few people do. Why? Okay. here at home is my TV. So on my desk at home, I've got a TV screen here, and I'm doing I'm creating new things over here. So now I've turned my one little machine into a TV and my computer support management device. So the variety of different ways in which program can be written is unlimited. The kinds of data and representation of information is equally unlimited. And so you're going to see that as things progress more and more, these computers are going to become more and more a central part of what you do. I asked the question, I probably asked the question before, how many of you have laptops? Now, when I asked that question 5 years ago, I had about, a third of the class. Now, when I ask that question, the majority of the class, because you realize that going to college and having a laptop is just, standard equipment, standard operating equipment. You have to have a laptop. Why? You have like paper, you have email, you have to have paper courses, you have to interact with me in such a way, and you don't always have access to the web. So you're going to see not only laptops being standard equipment, but wireless internet is now going to be proliferating throughout the city. So everywhere we go, everywhere you go, you're going to be able to get on the internet. It's like that in San Francisco, too, and some of the other more progressive cities on the West Coast. We're just slowly getting it done over there. Hopefully figure out. But when that happens, it's also part of this whole battle over the airwaves. Now, my phone and probably your phone can get on the internet. Now, has anybody ever, I'm sure some of you have, done voice over IP? Video conferencing with your friends over Windows Video Live? I love that. I chat on Apple. Now, can you see that replacing this? Suppose this was my iChat. iChat is free. I'm just going to get it. And my internet access is creating all throughout the home. Every place I go in Washington, D.C. You see, I won't have to pay for AT&T or singular monthly service on my phone system. There's it. There's some quality, and I'm sure commercial everybody when you plug something into the USB drive and you plug the phone in there, and now you've got voice over IP, now you've got this house phone door. Yeah, well, I don't know the name of it, but it's called Magic. They're making money hand over fist. It's like crazy money. I wish I had a picture of it. But voice over IP is going to basically revolutionize the phone. I can't wait. I don't know. A lot of money in my communication is I was doing a budget analysis just to see how much money I pay in every month for communication costs. Communication costs like cable TV, cell phone, landline, text messaging, and all the other stuff on my phone that I pay. It's almost as much as my mortgage, my house. It's a lot of money. Rivals paying for my car. It's just crazy amount of money is being poured into keeping me wired. I never, if I ever lose it, like my cell phone down in the sewer, I'm lost. I thought I'd take my trip. I didn't want to go out of town without my cell phone. But I did have my laptop. And I can use people's cell phones to send text messages and you can speak to them through my laptop. Okay, moving on. So we went over the control unit, we went over the arithmetic logic unit, the two components of the CPU. We talked about our devices, our living devices, our operating devices, and our main storage devices. And we didn't mention this very much, but our CD writers and our DVD writers were also living storage devices. Along with our modems and our communication with the internet, so the sound cards, digital cameras. Right now, I'm storing my lecture on digital camera here, and I'm storing it right into my hard drive. And now I've got 2 videos of what I'm doing up here and 2 audio courses. And I have a student that goes to first and read the history. Ethics. Good thing in the class. Ethics. One of the things that I think we have not really made any inroads into are the ethics of using computers. Ethics of using computers. Tell a quick story. I went to school, Georgetown University, many, many years ago. I had a roommate. I worked for someone before I came to school my freshman year, and I worked in the computer, and I learned how to write programs. And so when I got to school the freshman year, I worked in the computer center, work study. I had a roommate, smart guy. He wanted to make money like me. I was making money. He wanted to make money, so we had to teach him how to program. So I took some time, taught him how to program, and he ultimately, by the time he was a sophomore, had a job as a computer operator in the computer center. Working in the same place I was working. I was in the back writing programs. He was operating the computer office. He worked in the night shift, and he started pulling in big checks. Taking me out to dinner, buying me things. I said, man, you got drugs. What's going on here? He said, okay, I'm taking some of this stuff anyway. I changed grades. I'm going to the computer at night, $50 a grade. I'll change grades to and making 11 sessions. Well, Mark, tell him. Georgetown, I don't know if you know about it. Characterized him. He was a Georgetown student back in the 90s. He had every semester, every year, he would apply to principal, and they would approve him. He would do things, he would SAT, but he would never go. He had a back door. He knew he was going to get kicked out of Georgetown. He was in Dallas at the grade, but there were no laws in place to prosecute him. All Georgetown would do when they found out about this was kick him out of school. And he graduated from Princeton, still had a but at the time, there was no ethical laws. Now, right now, today, there are laws against doing that. You go to jail instead of prison. But we all do this. And, honestly, I have to thank my wife for making me stop. Because I was LimeWire and everything. Movies, everybody used to come LimeWire and after I was, that's what I did. And also, let's shut those things down in house. Because crazy. Some of the they just download music, put their iPods up, music library. So, is that ethical? Sure. That's a hard question. So, is it ethical to go to LimeWire and download? What do they use?
Time Paradise.
You just answered my question. So, again, the other stuff. Do you think it's ethical? Why? But it's not ethical. No more ethical than it is for you to take a copy of Microsoft Word and give it to your friend and say, hey, I bought it, you can get a copy of it. Why don't you buy it? So, it's not going to be long that stealing music is going to be a punishable, prosecutable offense. Companies have been prosecuted for allowing their employees to go in and to download music from resources. So, think about it. If you were a recording artist, Will Smith said it on his song, don't download and buy it. Don't buy my music, don't download. But if you were a recording artist, if you want your music out there, if you were a movie producer or actress, if you want your movie out on the internet to download it, second edition, That'd be cool, but I want to just lay off